Welcome to Educator.com. Today we're going to discuss equations in which the variable is on both sides of the equations. So far we've talked about isolating a variable, but in all the examples we've done, the variable was only on one side of the equation and we had to move around numerals to isolate the variable. This time we're going to see situations where the variable is on both sides. In order to solve more complicated equations such as this, we're going to be using the distributive property to remove grouping symbols. And we're going to be using the distributive property very frequently. The distributive property is named what it is because you can look at it as you're distributing something. You're splitting it up or you're distributing it differently. Reviewing what the distributive property is, what it says is that if you have A times B plus C, that is equal to A times B plus A times C. So instead of A times B plus C, you take the term outside the parentheses, multiply it by each of the terms within the parentheses. And when we move forward in that way, we're using the distributive property. You can also move the other way, go from AB plus AC back to A times B plus C, and that's called factoring, which is something we'll be discussing later on in the course. And this also holds true for subtraction. So if we have A times B minus C, we can use the distributive property to turn that into AB minus AC. Again, multiplying the A times the first term, keep your subtraction symbol, A times the second term. The way we're going to apply this is we're going to use addition, we're going to remove the grouping symbols using the distributive property, and then we're going to go back and use addition and subtraction to move all the expressions with the variables to one side of the equation, usually the left side, and then we're going to move all the numerical expressions to the right side. So get rid of the grouping symbols, move all the variables to the left, and all the numerical expressions to the right. There are several possible outcomes when you're solving these equations. There is the possibility that you'll have exactly one solution. So I might have an equation and I might end up with a solution where x equals 10. And we've seen that in the equations that we've worked out so far, where there's one solution. The other possibility is there actually may be no solution. For example, if I look at y plus 1, or if I look at y plus 1 equals y plus 2, there's not going to be a situation where this holds up. And you could use trial and error to examine this. Let's let y equal 1. Well, then that would give me 1 plus 1 equals 1 plus 2, which is clearly not true, because 2 does not equal 3. And you could try that with a bunch of different numbers. Here's something else you could do. You could actually solve this algebraically, or try to. If I have y plus 1 equals y plus 2, I can go about it my usual way, and I can move the variables to one side of the equation like we discussed. And I would do this by subtracting. You can subtract and add variables the same way that you can numerical expressions. So I have y plus 1 minus y equals y plus 2 minus y. Then what happens is my y's drop out. Y minus y is 0, so I have 1 equals, and then on the right side the same thing happens. Y minus y equals 0, so I have 1 equals 2. Since 1 does not equal 2, this equation is not true. So I would say that for this equation there is no solution. There's also situations where an equation is true for all real numbers. There's an infinite number of solutions. And there's a special name for these equations in which which are true for all real numbers, are also called an identity. So they're called identities. Here's one example. X squared equals x times x. Again, if I just substituted in and, used some trial and error, tried some different numbers just to test this out, I could see that if I let x equal 2, I would get 2 squared equals 2 times 2. And I could try that with any number. So that would be an identity. Or another example, a very simple one, would be y equals y. So no matter what y is, this equation is always going to be true. Most of the time, we're going to be working with situations where there's exactly one solution, but be aware that it could come out differently. So this is our first example, solving using multiple steps and having a variable on both sides. So I'm looking at this, 2n minus 7 equals 4n plus 6. Remember, what I want to do is move the variables to one side, all the expressions with variables in them to one side, and move numerical terms to the other side. Okay, so I'm looking at this, and what I have is 2n on the left and 4n on the right. And I want to move all the terms with variables in them to the left. Approaching this using the subtraction principle, in order to move the 4n to the other side, I need to subtract both sides by 4n. Okay, that gives me 2n minus 7 minus 4n equals 6. I'm going to simplify this, so I combine 2n minus 4n to get negative 2n minus 7 equals 6. Now I move the variables to one side. The next thing I need to do is move the numerical terms to the other side. So I want to move the negative 7 to the other side. And I'm going to do that by, since that's minus 7, I'm going to add 7 to both sides. And this gives me negative 2n equals 13. Now I'm down to something I'm familiar with, which is just needing to isolate the variable. And in this case, I'm going to use division. So I'm going to divide both sides by negative 2. Remember, keep it negative. And those negative 2's will cancel out. And I'm going to get n equals 13 halves. So negative 13 over 2. That is negative 13 over 2. Okay? So approaching this, first we got all the expressions with variables in them to the left side of the equation. The next thing we did was to move the expressions that were just numerical terms to the right side of the equation. So I did that down here. And that gave me minus 2n equals 13. After that, I need to isolate the variables. So move terms with variables to the left, numerical terms to the right, isolate the variable, and then you've solved the equation. Okay. In the second example here, I have grouping terms. I have parentheses. At the beginning of this lesson, I talked about how you sometimes need to use the distributive property in order to eliminate the parentheses before you can go any farther with these kind of equations. So once again, I have an equation in which I have variables on both sides. And first, I'm going to remove the parentheses by using the distributive properties. So remove grouping symbols by using the distributive property. So remember that the distributive property tells me that if I have A times B plus C, that is equal to AB plus AC. When I look at this equation, I start over here on the left side, and I'm going to eliminate these parentheses by multiplying 4 times, that's actually 2z, 4 times 2z to give me 8z plus 28. So 4 times 2z is 8z. 4 times 7 is 28. On the right side, I have 3 times 4z. That will give me 12z. 3 times negative 5 is going to give me negative 15. And then I also have a 7 there. And just to make this a little bit simpler, I'm going to combine these two numerical terms. So I'll have 8z plus 28 equals 12z minus 8. After I've removed the grouping symbols, the next thing is to move terms containing variables to one side. And I'm going to move the terms containing variables over to the left side. Right now, I have 12z on the right side. 8z plus 28. In order to move that, I need to subtract 12z from both sides. That's going to leave me with 8z minus 12z. I can combine those to get minus 4z plus 28 equals, the two 12z's cancel out, so that equals negative 8. Okay, so I've moved the terms containing variables all over to the left side, but I've still got a numerical term on that side. And what I want to do is move numerical terms to the other side, usually the right side. I can do that by subtracting 28 from both sides to remove the 28 from the left side. That gives me negative 4z equals negative 36. Once I've done that, now I just solve the equation. And I need to isolate the variable, which has a negative 4 multiplied by it. So I'm going to divide both sides by negative 4. When I work that out, it comes out to z equals 9. So that took a lot of steps, but you should always approach them in this order. Remove the grouping symbols first by using the distributive property. Then move the terms containing the variables to one side, move the numerical terms to the other side, and then finally solve the equation. Okay, in this next example we have 3 times 8w minus 7 over 4 equals 2 times 3w minus 8. Once again, I'm going to remove the grouping symbols first using the distributive property. I'm going to remove the parentheses. 3 times 8 is 3 times 8w is 24w. 3 times negative 7 is negative 21. And all of that is divided by 4. Equals 2 times 3w is 6w. 2 times negative 8 gives me 16. Negative 16. Okay, I've removed the parentheses, and the next thing is going to be to eliminate this 4 from the left side, because right now I can't really work with the term on the left when 24w minus 21 all is being divided by 4. So in order to move that to the right side, I'm going to multiply both sides by 4. Okay. The 4's cancel out. So now I have 24w minus 21 equals 6w minus 16 times 4. Using the distributive property, I can simplify this term. So 6w times 4 is 24w minus 16 times 4 is negative 64. The next thing is to move all the variables. Now that I've gotten rid of my parentheses, move the variables to the same side. And right now I have a 24w on the right side, but I only want variables on the left side. So subtract 24w from both sides. Well, here's where something strange happens. If I look at this, I have 24w minus 24w, so that's going to cancel out. Fine, I have minus 21. But I look on the other side, and the variable cancels out there as well. 24w minus 24w, that cancels out. What this leaves me with is that I have negative 21 equals negative 64, which is simply not true. So this is actually an equation for which there is no solution. And we talked about this before, and this is unusual. You're not going to see it very much, but it can happen. And I could have looked up here, and I would have seen that, well, this is saying 24 minus 21 is equal to 24w minus 64. And these two are the same, but these two are different, and therefore it doesn't work out. So there is no solution to this equation. Example 4 contains parentheses. So I'm going to start out by eliminating those parentheses. And recall, again, we're going to use the distributive property in order to remove the parentheses from the equation. 3 times 5k, that's 15k, minus 21 equals 3 times 6 is 18k. 3 times negative 2 is negative 6 minus 15 minus 3k. Okay, so looking at what I have here, what I can do is actually simplify the right side of that equation. I'm going to rearrange things so that I have like terms next to each other so I can see what's going on a little better. I have 18k minus 3k, and I have minus 6 and minus 15. Okay, that leaves me with 15k minus 21, 18k minus 3k is 15k. Minus 6 combined with negative 15 is negative 21. What I need to do after I've eliminated the parentheses is move all expressions containing variables to one side. Expressions containing or with variables to one side. And I'm going to get them on the left side. So I have 15k minus 21 equals 15k minus 21, and you may have already realized what's going to happen when I subtract 15k to move that to the left. $15k minus 15k, the k's drop out. That leaves me with minus 21. And if I look on the right, the same thing happens. 15k minus 15k drops out. And what I'm left with is true. Negative 21 does equal negative 21. So the solution to this equation is that the equation is true for all real numbers. No matter what k is, this equation is going to hold true. So this was our last example for today's lesson. Thanks for visiting educator.com.